Okay, JK, this is for you and anyone else who wants to listen. So what I've done is this is the first function that you looked at on Desmos, and I'm going to look at it graphically and numerically because it might help you. So you can see in blue, that is the parabola, which is f of x. And then you guys used your Desmos activity to create the derivative of x. And this makes sense because we know the derivative of x squared is 2x. So I just plotted some points here. And so let's look at the table and the graph. So my question for you is when f of x is increasing. So that means from, let's see, I should use a different color. From 0, oh, not red, black. From 0 to infinity, f of x is increasing. Well, what do you notice about the slopes, the derivative? Well, if you look here, the derivative is positive. So when f of x is increasing, then f prime of x is positive. And does that happen in the table also? So here we can see that f of x is increasing, going from 0, 1, 2, 3. And we see then also that the derivative, I'm sorry, I drew the arrow the wrong way. Here, f of x is increasing. It's going from 0, 1, 4, 9, and the sign is positive. Okay, now let's look at when f of x is decreasing. So we can see from negative infinity to 0, the graph is decreasing. Oh, my pen's not ready. There we go. The graph is decreasing. So when the graph is decreasing, we can see here that the slope is negative. So when f of x is decreasing, then f prime x is negative. Now this graph is concave up during the entire interval. It's shaped like an open cup. Now let's look to see what we notice about f prime. On the entire interval, how would you describe the y values? They start at -8, -6, -4, -2, and 0. So they're not all the same sign, but do you notice that they're always increasing? So when this graph is concave up, I notice that f prime is increasing. Now at the minimum value of f of x, so that would be at 0, 0, at the vertex, we know that at 0, 0, the derivative is 0. So this graph at 0, 0, f is changing from decreasing to increasing. Well, what is the sign of the derivative changing from? It's changing from a negative to a positive. So at the minimum, the derivative equals 0, and f prime changes from negative to positive. Let's look at it another example. So the second example you were given, it appeared to be an absolute value function. And we know an absolute value really is a piecewise with two linear pieces. So f of x is increasing from negative infinity to 0. So when f of x is increasing, what do you notice about the values of the slope? Well, they are positive. When f of x is decreasing from 0 to negative infinity, what do you notice about the values of the slope? Well, the values are all negative. Sorry, I should have made that a little smaller. So they are negative. Now in this graph, at the maximum, so the maximum is like 0, 8. Oh, what's going on there? That's interesting. The derivative does not exist. That's because the slope from the left is not equivalent to the slope from the right. And at the maximum, f is changing from increasing to decreasing, while f prime is changing from positive to negative. Okay.